Bird migration is a passion for me, the spectacle of it, the mystery of it. My name is Andrew Farnsworth. I'm a research associate at the Cornell Lab of Ornithology. I've been affiliated with New York City Audubon now for probably about a decade, both as a board member on the advisory council and probably most exciting, working directly with Susan. I think that the work that we've done together has been transformative. My research focuses on looking at nocturnal bird migration in particular. There's still quite a lot we don't know about simply the patterns of when large numbers of birds move where and under what conditions, and I'm answering some of those questions with a team of collaborators right now. If you are really lucky, you have the capability to look inside this mysterious world of all the movement at night using these cool tools. BirdCast is an amazing collaborative project. It's an effort between computer scientists and ornithologists, basically to try to predict the movements of birds. Right now there are 143 radar stations in the continental US. When you look at the raw radar data that you might see from a smartphone app, you see everything that's up in the atmosphere. So you see meteorology, you see where precipitation is associated with cold fronts, and then when the sun sets, this incredible bloom of biology in the atmosphere, this unique blue and green, often stippled pattern. NOAA, National Oceanic and Atmospheric Administration, through the National Weather Service, has been archiving these data. We're talking about a 2.5 decade archive of information where we're using algorithms to take out the meteorology, take out the precipitation, and actually to try to remove things like insects and bats. You get this sense of, wow, there's a tremendous amount of bird activity happening at night. What's happening behind it is something we understand. Probably 50% of the birds that migrate annually at night in the spring pass through the country on 7 to 10 nights. We're talking about maybe 400 or 500 million birds on a good night. BirdCast offers an opportunity to really understand, well, all right, if I want to see a lot of birds, or if I want to understand why I'm seeing a lot of birds, where would I go, or where have I been? There's a real connection to the hobby, the passion, the pursuit that is absolutely what is at the core of BirdCast, no question. But there's another level as well, using birds as a way to study what's happening in the environment, studying the way climate is changing, studying the way habitat loss or urbanization affects the way birds move in space and time. This information that we can provide and extract can actually do some incredible things from a conservation perspective, being able to say there's a certain density of birds above a city right now that are attracted to a particular light feature. Let's extinguish lights. When would it be a good idea to alter our behaviors, whether it's energy infrastructure or flight traffic or even application of pesticides, where to put green spaces or why? This kind of information is what we can provide to try to make changes in the way we behave. There's absolutely a climate change piece to BirdCast as well. We can understand how numbers of birds aloft have changed, whether the timing of migration has changed, how it's changed in different places, and really putting numbers on migrations. eBird has now been around for probably a decade and a half. It's an online checklist program, so it gives people, any birder, any scientist that's interested in birds, the ability to enter what birds they're seeing, how many, wherever they are, anywhere on the planet, whenever they want, in a relatively short period of time. It's allowed an armada of citizen scientists to go out and collect hundreds of millions of observations about where birds are when. Where did I see a house sparrow today? Where did I see a merlin yesterday? That kind of data can grow into cutting edge maps of where do we predict species to be on the landscape now, with what habitats are they associated, relative abundance, frequency of occurrence, all sorts of cool information about where birds are when, the way that birds can and do go from one place to another via the same stopover habitat every year, similar paths, yet have all of these challenges that they have to deal with and this incredible machinery to do it. There are many, many things about it that capture the imagination, and it's done so for me for decades at this point.